Today we're going to talk about synthetic division of polynomial functions. We will learn how to apply synthetic division in two different scenarios. The first scenario is when we are dividing by a binomial in the form x minus b. So in this example, we have to divide this polynomial function by x minus 3, so our b value is equal to 3. Using synthetic division, we place the b value of 3 over to the left of the table, and then we lay out the leading coefficient of each term on the right side. We have 2, we have 5, negative 13, and 6. And then we look over here, and this is the general rule where we just bring down, multiply, and then add. So here we bring down 2, and then we multiply this 2 by 3, which gives us 6, and then we add 5 plus 6, which gives us 11. And then 11 times 3 gives us 33. Negative 13 plus 33 gives us 20. 20 times 3 gives us 60. And 60 plus 6 gives us 66. The last term below the chart is always going to be the remainder. And then for the remaining 3, we label them from right to left, starting with the constant. And then we have the variables of x in increasing degree, so x1 and then x2 and then x3 and so forth. So our answer is 2x squared plus 11x plus 20. The second scenario is when we're dividing by a binomial in the form ax minus b. We first need to factor the coefficient of x to change this into the form x minus b. So when we factor, we get this, and then we get a value of b of negative 3 over 2. After that, we then have to divide the polynomial by its b value, and then divide the quotient by the 2 you factored out. So we have our b value of negative 3 over 2 to the left side, and then we have our leading coefficients lined out. And then we remember our rule of bring down, multiply, and add. So we bring down 4 over here, and we multiply that by negative 3 over 2. That gives us negative 6, so we add 8 plus negative 6, gives us 2, and then 2 times this gives us negative 3, negative 13 plus negative 3 gives us negative 16, negative 16 times negative 3 over 2 gives us 24, and 12 plus 24 gives us 36. And remember that the last term under the chart is always going to be the last number under the chart is always going to be remainder. The extra step in this scenario is to divide the quotient by the 2 which we factored out. So we divide the quotient by the 2, which gives us 2, 1, and negative 18. And then we can label as normal with from right to left, starting with the constant and then the variables in increasing degree. So our final answer for this problem is 2x squared plus x minus 8. Now, how is synthetic division applied in the real world? It can be applied in finances to determine the point in a graph where the increase or decrease in sale can equal to 0, and also in computer science to help design and fix algorithms, and in other many different sectors as well. Before I end up this video, I'm just going to do a quick learning check. When does synthetic division work best? Is it option 1, 2, or 3? Pause before you answer. And we have 3, when the coefficient of the binomial is 1 and has a degree of 1. That brings me to the end of my video. Thank you for watching.